Hi, Mr. Biggers here, and today we are going to go through our Unit 4, Lesson 1, the Introduction to Transformations. Before I get started with these notes, I just want to add that depending on the version your teacher chose to use, your notes may look a little different than mine. That's okay. We're going to go ahead and get started. So, to start here, a transformation in general is a change to a geometric figure's position, size, or orientation. So remember, orientation means what direction are you facing, okay? So a rigid motion, this is important. You want to know this word. It's a transformation that moves a figure but does not change its shape or size. It preserves distance and angle measures. And remember, if the distance and angle measures are preserved, that means it's congruent. This is also known as a rigid transformation and isometry. Those words mean the same thing. So we're going to look at the following three examples and determine which form of isometry or rigid motion is shown for each example. So here, for example A, we can see that the images are reflected, okay? It's a mirror image. Okay, so the image is reflected, or the pre-image is reflected to create the image. All right, so it's a mirror. All right, part B here, we can see that we start at our original pre-image here, and that image is then rotated, okay? Now, if it rotates this way, where the arrow is pointing, that is known as a clockwise rotation. So this is a rotation. We could also call it a turn. Okay, and then here on C, I'm going to start with our image. So I'm going to start with our original figure here. And then if an image slides over to a new image, that is known as a translation. So it slides. That's known as a translation. Okay? Okay. Once again, the pre-image is the original figure, okay? The image is the new figure, okay? Very important. So think of a preview of a movie, okay? That's before you see it. The movie, you're going to see it, and then after the movie is the after effects. So the pre-image is before you move it. The image is after. So I'm going to come over here to dilation. So a dilation is a proportional increase or decrease in size in all directions. That means everything will grow by the same amount or everything will shrink in the same amount. Dilation is the only one we're going to learn that is a non-rigid transformation. Dilations do not preserve distance, but they do preserve their angle measures. So a good real-world example to think of a dilation is to see a small stop sign in a parking lot somewhere, and on the main road, you see a larger stop sign. They are exactly the same shape because the angles are the same. However, the size of each side is different because it is dilated, either bigger or smaller, okay? So let's answer these questions about dilations. Will the image change its size? Absolutely. You can see that in the picture. Does dilation preserve distance? No, it does not preserve distance because you can see here, this side got much longer in the new image, okay? If I move it, you can see it got much longer, okay? Is this isometric? It is not, okay? Isometry requires the preservation of both size and distance between points and the angles, okay? So it's not an example of isometry. It's not a rigid motion, okay? So we're going to come down here to a translation. Now, once again, a translation is a transformation in which every point in a figure is moved in the same direction and by the same distance, okay? So we are going to jump into here with example 1. So we're going to start with the image. So the original figure is, it looks like it's a rectangle, A, B, C, D here. So you can see that rectangle. It is slid or translated 7 units to the left. So 1, 2, 3, 4, 5, 6, 7. And then it is translated down 9 units. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that is a slide or a translation. It's translated 7 units to the left and 9 units down, okay? These images here, we can see that I have a pre-image, and this is my image, okay? So what I do to figure this out, how did it move? I pick any point. So let's just say I pick point B. So let me get a different color here. So I'm going to do purple. So here's my point B. And I need to see how much does this point move between the original point and the new point. So I'm going to take this point and I'm going to move it. We're going to count left or right first. So it moves 1, 2, 3, 4, 5, 6, 6. Okay, so it moves 6 units left. I'm going to keep that point right there for now. So it translates 6 units left. Fit it all on the same line there. Okay, and then to get from this purple point up to the new point B, you have to move up 1, 2. So it moves 6 units to the left and up 2. Okay? So keep that in mind when describing a translation. Okay? So will the image change its size? Absolutely not. It's going to be the same exact size. Does a translation preserve distance? Yes, we saw that. The side lengths are exactly the same. So it is an example of isometry. It is isometric. It's a rigid motion. All of those things mean the same definition. Okay? That's the front page. We're going to go ahead and move on to the back page at this time. So a rotation is a transformation that turns a figure around a certain point by a certain number of degrees, either clockwise or counterclockwise, okay? So clockwise is here in this first example, okay? And this would be counterclockwise. So a clock rotation, if I had a clock, it's going to go that way. The hands of the clock move this way, okay? So that's clockwise. Counterclockwise is going to go the opposite direction, okay? So it's important to understand a 90-degree rotation clockwise is going to be a 270-degree rotation counterclockwise, okay? So 90 degrees clockwise is 270 counterclockwise. We're going to talk about these right now in these examples, okay? So you can see my original figure here, okay? It is rotated, or it is turned, okay? And that would be a clockwise rotation. So I would say 90 degrees clockwise. And remember, that could also be all the way around there. It could be 270 degrees counterclockwise. A full rotation all the way back to the original figure would be a 360-degree rotation, okay? So moving on to example 2 here. From the original figure, the pre-image to the image, it rotates past 90 degrees because a 90-degree rotation would have this figure turn on its side. But in this event, we see that the figure is flipped upside down, which means it was a 180-degree rotation. that is going to be the same counterclockwise or clockwise. It does not matter because 180 degrees will always end up in exactly the same spot. Okay? So, will the image change its size? So we can clearly see here in these two examples, no, it does not change its size, okay? Does the rotation preserve distance? Yes, it preserves distance between the points. Is it isometry? Is it isometric? Absolutely yes, okay? It is a rigid motion. It preserves both sides of the shape and the angles and the distance between the 2 points. So that is a rotation. Last but not least, we have a reflection. This is a transformation that produces a mirror image of a geometric figure. Okay? So we can see here we have a reflection on the coordinate plane. So let me go ahead and clean this up here so we can get into it. So a reflection here in the y-axis is going to be your vertical axis. That's your up and down axis here, okay? So a y-axis reflection is going to make your x-coordinate the opposite. Okay? So it's going to negate your x value. A good example is at this point C over here, x is equal to 7, okay? Now, that is the pre-image. In the image over here, C prime is going to be x is equal to -7. It makes your x opposite, okay? Another thing that I want us to write is C prime, okay? That's red, C prime. That means it is the image, okay? It's the copy. So that's something important that you might want to remember. Highlight that too. Definitely important to remember that, okay? And then here we have a reflection over the x-axis, okay? So the x-axis is gonna be that horizontal axis, okay? And it does the same exact thing, but it makes the y negative. So, and I don't like to say negative because it negates the y. So if the y value was -2, it would become +2. So I'm going to pick on point B here. The y coordinate for B is 6. So the y coordinate for B prime is -6. That's a reflection over the x-axis, okay? You can see it's a mirror image. It is still the same shape and size though, okay? And then over here, this is another common example you're going to see in geometry. It reflects across the line y equals x. So you need to remember slope-intercept form. We have y equals mx plus b, where m is the slope of the line and b is the y-intercept. So the line y equals x is just a line that has a y-intercept of 0 and a slope of 1. So it's going to go up 1 over 1 from that point. So this dark line that I'm making here is that line. This is a line of reflection. So you can see, since the shape passes through that line of reflection, so I'm going to start with the original shape here. It has to be reflected through that line, okay? So how do you do a reflection over that? All you do is flip the x and the y, okay? And I'm going to show you that right now. So point C in the pre-image, the coordinates of that are 7, 3. The reflection coordinates here, you can see, are 3, 7. That's a reflection over the line y equals x. So that is a very important thing that you'll want to remember and notice, okay? So come over here. Let's describe these. See if you can pause the video and figure this out based off the notes. Example 1, the description for example 1, it reflects over the x-axis. Okay, you can clearly see that it's a reflection over the x-axis, okay? In example 2, the answer reflects over y-axis, okay? So will the image change the size from the pre-image? Absolutely not. It will not change the side. Does it preserve distance? Yes, the distance between 2 points in a figure is exactly the same. Is this isometric? Is this isometry? Is it a rigid motion? Yes, it is a rigid motion. Nothing changed. The only one that we've talked about on these notes that is not a rigid motion would be your dilation. Okay. So pause this video at any time. Here are the notes. This is the front page. Here's the back page. Make sure you have these and use this to study.